In this video, I will be giving the review about vector algebra. So let's start. First, I will be giving you the brief outlines of the related topic which we have to focus. So first topic will be about the scalar and vector quantity. Then we will be taking basics of vector, unit vector, and lastly we will discuss about the position and distance vector. So let's start. The basic difference between scalar and vector quantity is a scalar is a quantity that has only magnitude, while a vector is a quantity that has both magnitude and direction. Let's understand this by taking an example of both scalar and vector quantity. For example, the time is scalar quantity while velocity displacement is vector quantity. Why it is so? Because distance is both traversed by anyone in it contains overall magnitude no matters how and in which direction it is moving. But when we say displacement, we always consider its initial and final position in order to get the value of magnitude as well as its direction in which the body is displaced. So coming back to the slide, scalar is one dimensional quantity while vector is more than one dimensional quantity. Scalar can be divided by another scalar quantities, whereas vector cannot be divided with another vector quantities. Scalar quantities are represented by A, B, C, whereas vector quantities are represented by A, B, C with arrowhead and etc. For example, time, mass, distance, temperature, density, electrical potential are scalar quantity, whereas velocity, force, displacement, electric field intensity, etc. are vector quantities. Now, I will be giving you the basic idea of vector. First, I will discuss how a vector A can be represented in the Cartesian coordinate system. For example, vector A can be represented as x cap ax plus y cap ay plus az z cap, or we can also represent vector A in the bracket form like ax comma ay comma az, or also we can represent in ijk form like I cap ax plus j cap ay plus k cap az. Whenever I am saying vector A, it means A is with arrowhead. No need to say only A or only A with arrowhead. Just vector A signifies A as it has direction and vector quantity with arrowhead. So the vector A has three components mainly Ax, Ay and Az in the x, y, z direction respectively. Therefore, the magnitude of vector A is represented by mod of A, which is given by mod of A equal to the summation of square of all the direction components. That is, mod of A can be written as square root of ax square plus ay square plus az square. Now, what is unit vector? A unit vector is defined as a vector whose magnitude is unit. Let's take a vector A which is represented as vector A is equal to x cap ax plus y cap ay plus az z cap. Here ax, ay, az is magnitude component in x, y, z direction respectively. The unit vector in the direction of vector A can be written as AA, that is equal to vector A divided by mod of A, and this is equal to vector A divided by square root of ax square plus ay square plus az square. Let's take an example of unit vector where we have to find the unit vector extending from the origin towards the point G. Here the point G is any point in space whose coordinate is 2, -1, -2. This example will give you a brief idea for approaching the uses of unit vector. So what we have to do now? First step is to construct the vector extending from the origin to point G. Look at the origin. Look at the given coordinate points of G, that is 2, -1, -2. So write coordinate with its direction and we get vector G is equal to 2x cap minus y cap minus 2z, as we have the coordinate 2, -1 and -2. Now calculate the magnitude of vector G. Magnitude of vector G is written as mod of G. This is equal to square root of 2 square plus square of -1 plus square of -2, and this will comes to be 3. Therefore unit vector can be written as vector G divided by mod of G. So after solving we will get 2 by 3 x cap minus 1 by 3 y cap minus 2 by 3 z cap. For further simplification, you can write these fraction value in terms of decimal value also. So the final answer will be 0.667 x cap minus 0.33 y cap minus 0.667 z cap. Now I will discuss about what is position and distance vector. As you know, a point P in Cartesian coordinate may be represented as Pxyz. So the position vector at point P is the vector from origin O to point P, that is denoted by vector Rp. That is the position vector of point P. Let's take an example. Vector Rp is given as 3ax plus 5ay plus az. So in this example you can see 3, 5 and 1 is the position of point P in the Cartesian coordinate system. So point P is represented by vector Rp with the unit vector. Now for calculating the distance vector, let's take two position vector rq and rp for the point P and Q from origin O respectively. So the distance vector can be defined as rpq. That can be written as vector rpq is equal to position vector of Q, that is rq, minus position vector of P, that is rp. For better clarification, let's take an example where P and Q are the point located at 1, 3, 4 and -2, 3 and 1. Here coordinate of both points are given already. You just have to calculate the position vector P and the distance vector from P to Q and distance between P to Q. So let's solve this question. The first is the position vector of P. So position vector of P can be written as 1ax cap plus 3ay cap plus 4az cap, because we have the position of P 1, 3 and 4. So finally it will ax cap plus 3ay cap plus 4az cap. And second is the distance vector from P to Q. As we know, the position of P and position of Q. So vector PQ is what? That is the vector Q minus vector P. So the position of vector Q is what? That is -2, 3 and 1 minus position of vector P, that is 1, 3 and 4. After solving we will get -3ax minus 0ay minus 3az. that is equal to basically minus 3ax minus 3aj. And the third question is what? That is the distance between P and Q. Since vector PQ is the distance vector, the distance between P and Q is the magnitude of this distance vector, that is A. So A is the basically magnitude of what? That is the vector RPQ. So this can be solved. Square root of minus 3 square plus 0 square plus minus 3 square, because we have the x component with magnitude minus 3 and z component with the magnitude minus 3. We have 0 component in the z direction. So after solving this, we will get 4.24. This is the basically scalar quantity and it is the distance between point P and Q. So thank you for watching this video.